Here's a true response question from an A/B practice test. Let's see what we got. Functions f, g, and h are twice differentiable functions. That just means all the theorems that we know would apply to these. These are nice smooth curves. With g of 2 equals h of 2 equals 4. Okay. The line y equals 4 plus 2 over 3 times x minus 2 is a tangent to both the graph of g and h at x equals 2. Okay, so they both also have the slope, so that means g prime of 2 is the same as h prime of 2, which would be 2/3. That's the slope, right? Slope of the tangent line, slope of the function is the same. Okay. Find h prime of 2. Well, I guess I just did that. H prime of 2 is equal to 2/3. There's no work to show there. It's just that. So that's it. Let a be the function given by a of x is equal to this. Write an expression for the derivative and then find a prime of 2. Okay, so they're just seeing if we know some derivative rules here. So if a of x is equal to 3x cubed times h of x, then I would have to use the product rule to find that a prime of x is equal to derivative of the first times the second plus the first times the derivative of the second, and then a prime of 2 would be equal to 9 times 2 squared is 36 times h of 2 is 4, right? Remember they told us that? Plus 3 times, let's see, 2 cubed is 8 times 3 is 24 times h prime of 2 is 2/3. That is an all numeric answer, so you do not have to do any more work. But if you did, it's equal to 160. Oops, dropped my pen. Got it back. Part C. Function h satisfies h of x is equal to this for x values not equal to 2. It's known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. So they want us to use limit as x approaches 2 of this to find f of 2 and f prime of 2. Okay, let's see if we can do that. So they want us to do L'Hopital's rule. So I'm just going to jump in and say, okay, so that means that the if we're going to find limit as x approaches 2 of h of x, which is this, x squared minus 4, 1 minus f of x cubed. We know that when we do this, so first of all, they're telling us that L'Hopital's rule can be used. That means that when I plug 2 into this, I've got to get 0 over 0, right? And sure enough, when I plug 2 in the top, I get 0. But that means that I must also get 2 when I plug 2 in here, which means that f of x cubed must be equal to, f of 2 cubed. Right, when I plug 2 in here, that has to come out to be 0. So f of 2 cubed has to be 1, and that means that f of 2 cube root of 1 is 1. So it has to be, because they said that you can use L'Hopital's rule, and L'Hopital only applies if you get 0 over 0 or infinity over infinity. That's a tricky little, that's an unusual way of approaching a L'Hopital question. But hey, got to be ready for anything, right? And I also know that if L'Hopital's rule can be used on this, then the limit as x approaches 2 of this, and this thing's a continuous function, and I know that h of 2, I know that when I plug 2 into the h function, that it's equal to 4. So I also know that I have to get 4 when I do it, right? Okay, so let's actually do L'Hopital's rule on this and see what happens. So L'Hopital's rule says you can take the derivative of the top, and then the derivative of the bottom, that's gone. On the bottom I would have minus 3 times f of x squared, right? It's 3 is coming to the front, goes down by 1, but there's an f of x on the inside, so I'd have to multiply by the derivative of what's inside. Okay, so what L'Hopital's rule says is that if you do that, then you get the actual answer. And I know that that's 4, right? I know that it's going to be equal to 4. So when I plug 2 into all this, it's got to be equal to 4. So let's just do that and see what happens. So 2 times 4 on the top is 8. Negative 3 times f of 2. Hey, I just found that. It's 1. That's times 1 squared times f prime of 2. That has to equal 4. And then I think we should be able to do it from here. Is it like negative 2/3 when you simplify that? Let's see. Did I do that right? Prime of 2. I put 2 in. Oh, except for the fact that 2 times 2 is not 8. Sorry about that. 2 times 2 is 4. Right? Okay, so I think when we simplify that, then move this over here, that's negative 1/3. So f prime of 2 has to be equal to negative 1/3. That, my friends, is a pretty tricky question, but that's how you do it. You just have to think about what do you know about L'Hopital's rule and use those facts. Oh, I hope I wasn't talking about all that when that was off the screen. Sorry about that. So that's all the stuff there. That's actually doing L'Hopital's rule, getting the 2x, and doing, there's some power rule and chain rule there to get that derivative. And then I know it's got to be equal to 4. And then it's just algebra after that. Okay? It is known that g of x is less than h of x for values between 1 and 3. Okay? And let k be a function satisfying it's in between those. So is this that like squeeze theorem or sandwich theorem it's called sometimes? Is k continuous at x is equal to 2? Okay. Well, is k continuous at x equals 2? I think that it has to be because of the squeeze theorem, right? So by the squeeze theorem, that, if you want to go back and look at that, I think that we saw the squeeze theorem, I do believe that was in section 2.5. 2.5 or 2.6. It was with the squeeze theorem that we got the result that the limit as x approaches 0 of sine of x over x is equal to 1. That was the squeeze theorem result, way back in chapter 2. So by the squeeze theorem, if g of x is, well, if k is squeezed between these, and I know that these two functions, the g function and the h function, when I plug 2 into them, they're equal to 4. G of 2 and h of 2 are both equal to 4. So those are coming into the same point. And those are twice differentiable functions, which means they're also continuous. So if this is continuous and this is continuous, and k is trapped between them, that means that the limit as k approaches 2 of, as x approaches 2 of k of x must be equal to 4. And if this limit here exists, and that's trapped, I know that g of 2 if I plug 2's in here, which I can, of course, because I said it works for all these values in between 1 and 3. If I plug that in, I know that g of 2 is 4, and h of 2 is also 4. So k of 2 has to equal 4 also. There's no other way. It can't be trapped between those two and not go through that point. 2, 4. I think I messed this pen up when I dropped it. I don't like the way it's writing now. So if this is true, and the limit is k as x approaches k, it's also approaching that. That means, so k is continuous, because it's approaching that point, and it's actually equal to that. So that's the definition of continuity. X equals 2. All right.